There is one mistake that destroys AI interviews before the candidate even realizes what happened. It is not always a wrong formula. It is not always a missing definition. It is not even always a coding mistake. The real mistake is answering like a model trainer when the company is looking for a system thinker. That is the quiet filter inside many serious AI interviews. The panel may not call it a filter. They may not say, "We are testing your architecture mindset now." But when they ask you to explain a project, design an AI system, or solve a business problem using machine learning, they are not only checking whether you know algorithms, they are checking whether you understand how AI works outside a notebook. And that is where many candidates struggle. They walk into the interview ready to talk about accuracy, datasets, training, and model names. They mention random forests, transformers, LLMs, CNNs, XGBoost, fine-tuning, vector databases, and RAG. All of that can be useful. But in an enterprise interview, those words are not enough. Because real AI work is not just about building a model. Real AI work is about building something that can survive real users, messy data, changing requirements, security concerns, privacy rules, cost limits, latency limits, monitoring problems, and business pressure. That is why the most dangerous interview questions often sound very simple. The first one is, walk us through an AI project you built. Most candidates answer this like a timeline. They say, I collected the data, cleaned it, trained the model, evaluated it, and deployed it. That answer is not wrong, but it is incomplete. It tells the panel what happened, but not how you think. A stronger answer begins with the problem. For example, instead of saying, I built a classification model, say, the goal was to reduce manual review time by classifying incoming requests into priority levels. The main constraint was that false negatives were more costly than false positives because missing a high priority case could delay response time. So I optimized the model around recall for the high-risk class, not just overall accuracy. That one answer immediately sounds more mature. Why? Because you connected the model to the business problem. In real hiring, structured interviews are often built around consistent questions and scoring rubrics. That means interviewers are not only listening for impressive words, they are comparing how candidates explain decisions, trade-offs, evidence, and results. A candidate who can clearly explain problem, constraint, decision, result, and lesson will usually sound stronger than someone who only lists tools. The second question is even more revealing. How would you design this AI system for production? This is where many candidates make the same mistake. They jump directly to the model. They say, I would use a transformer, or I would fine-tune an LLM, or I would use XGBoost because it performs well. But in production AI, the model is only one part of the system. A stronger answer starts with questions. What is the user trying to do? How fast does the response need to be? What data is available? Is the data sensitive? How will the system be monitored? What happens when the model is wrong? Does a human need to review high-risk decisions? What metric actually matters to the business? These questions do not make you look uncertain. They make you look experienced. For example, imagine the panel asks, how would you build an AI system for customer support? A weak answer says, I would build an LM chatbot trained on company data. A stronger answer says, first, I would define the use case. Is the system answering simple FAQs, helping agents draft replies, routing tickets, or fully resolving customer issues? Then I would check constraints like privacy, hallucination risk, response time, escalation rules, and audit requirements. I would likely start with retrieval augmented generation using approved knowledge-based documents. Add citations or source references, and create a human handoff for uncertain or sensitive cases. I would evaluate it using answer accuracy, escalation rate, customer satisfaction, average handling time, and hallucination rate. That answer shows architecture. It shows that you understand the full workflow, not just the AI model. This matters because trustworthy AI systems are judged by more than performance scores. NIST describes trustworthy AI using characteristics such as validity, reliability, safety, security, resilience, accountability, transparency, explainability, privacy, and fairness. In simple words, a real AI system must not only work in testing, it must work safely and responsibly in context. The third question is one of the biggest traps. Your model performs well in testing, but fails after deployment. What do you do? This question is powerful because it exposes whether you understand the difference between lab performance and production performance. A beginner may answer, I would retrain the model. That may be part of the solution, but it is not enough. A strong candidate would say, first, I would compare training data, validation data, and live production data to check for distribution shift. Then, I would inspect whether the input features changed, whether user behavior changed, whether the labels are delayed or noisy, and whether the model is failing for specific subgroups. I would review logs, monitor confidence scores, check false positives and false negatives, and look at whether the original evaluation metric matched the real business objective. After identifying the cause, I would update the data pipeline, retraining process, threshold, monitoring dashboard, or human review process. That answer shows real-world thinking. Because in production, models fail for many reasons. Data changes, user behavior changes, labels are wrong, business rules change. A new product feature changes the input distribution. The model sees examples it never saw during training. The system may also fail because the model is technically accurate but operationally useless. This is why accuracy alone is often not enough. If you are working on fraud detection, a model with high accuracy may still miss the rare fraud cases that matter most. If you are working on medical triage, false negatives may be much more dangerous than false positives. If you are working on content moderation, precision and recall may need to be balanced with human review capacity. If you are working on recommendations, user satisfaction and long-term engagement may matter more than a simple offline metric. Strong candidates know how to match the metric to the problem. They do not say, my model got 95% accuracy, and stop there. They explain what the metric means. They explain what the model gets wrong. They explain who is affected when it gets something wrong. They explain how they would monitor it after deployment. That is the real interview advantage. Not hype, not buzzwords, not pretending every problem needs the most advanced model. In fact, one of the smartest things you can say in an AI interview is, I would start with a simple baseline. That sentence shows maturity. A simple model gives you something to compare against. It helps you understand whether a complex model is actually worth the cost. In many business settings, a clear, fast, explainable model can be more valuable than a large model that is expensive, slow, hard to monitor, and difficult to explain. This is especially true when the company needs interpretability, compliance, or fast decision-making. The best AI candidates understand trade-offs. They can say, a larger model may improve performance, but it may increase latency and cost. They can say, a more complex model may improve accuracy, but reduce explainability. They can say, a fully automated decision may be faster, but a human-in-the-loop process may be safer for high-risk cases. That is the kind of thinking panels respect. So how should you answer these questions? Use this structure, problem, constraints, architecture, evaluation, failure plan, and business impact. Start by explaining what problem you are solving and why it matters. Then cover the limits, such as data quality, privacy, cost, latency, fairness, security, or explainability. After that, explain the system architecture, how data enters, how it is processed, what model you would use, and how results are delivered. Next, discuss evaluation. Do not only mention accuracy. Talk about precision, recall, F1 score, latency, cost, user satisfaction, or the business outcome. Then explain your failure plan, what happens when the model is uncertain, how you monitor drift, and when a human should step in. Finally, connect everything to business impact. Did the system save time, reduce cost, improve reliability, support customers, or reduce risk? That is how you move from sounding like someone who studied AI to someone who can own AI in the real world. In serious interviews, the strongest candidate is not the one with the fanciest algorithm. It is the one who understands the whole system. Before your next AI interview, remember, do not just explain the model. Explain the problem, trade-offs, metrics, and business impact. If this helped, subscribe and turn on notifications. Thanks for watching.